right, sharing screen now. Today we have 2332, the latest time to catch bus. Another medium, we're gonna solve it in Python. You're given a zero-indexed array buses with len and buses I represent the departure time of I bus. You're also given zero-indexed array of passenger, where passengers J represents the arrival time of J's passenger. Our bus departure times are unique. All passengers' arrival time are unique. Okay, you're given capacity, which represents the maximum number of passengers that can go on each bus. When a passenger arrives, they will wait in line about behind. You can get bus depart 6 minutes if you arrive 1 minutes where the bus. When a passenger arrives, they will wait in line. You can get on a bus that departs X minutes if you arrive and Y minutes where X minus Y. Okay, so if you arrive earlier, but still you are like have to wait in a line and the bus is not full. Passenger with the earliest arrival time will go on the bus first. Okay, more formally, bus arrives after if capacity is fewer passenger waiting on the bus, they will get on a bus, or the capacity passenger with the earliest arrival time will get on a bus. Return the latest time, you may arrive at the station for each bus. You cannot arrive at the same time as another passenger. Same time. Okay, the arrays buses are not necessarily sorted. Okay, so this is a similar way we have similar pattern we have for optimization function parameters. So we have a function parameter. Let's call it can I catch bus at time. So we have this function, and that function will describe the entire thing with passengers arriving and buses arriving, and we probably, in order to implement this function, we will have to sort passengers that are not necessarily sorted. So we have to sort passengers. So it probably have to do it before calling function because we might have a call function a couple times. So sort passengers and buses. And then we have to implement function. We will go we will have to calculate max mean time, max time, the same for passenger. So we calculate mean passenger time and max. Equal mean passenger and max passenger. Then we will iterate. Function itself will be returning true, false. So now what it will do? It will we will iterate from mn to mx for a time in range And then so we will accumulate Q, create Q. Now let's call it Q, and we will just add passengers we have right now, and in so we call passengers and we sorted passenger, and we called bus and we sort our buses, right? Let's call it sorting. So, and we just add everything that we have in a passenger for this time. But how are we gonna see this, right? See, first arrive on 2, other arrive on 17, but first we'll go on 10. Okay, so I have to create, probably I have to create also horse table from map from passengers, so I will know if passengers arrive at this time or not. And it will be like okay, so for example, if we create hash set or hash set from passengers. Then we will, if passengers if passengers contain time, right, we just add this passenger to queue. If bus contains time, we will q minus equal capacity. Q abs q. Or like this, abs absolute value from q minus capacity. So at this time, we simulate the entire process, right? We with time flow as time flows from Uh, we have here this example. As times go from here to here, and we have here first 2, then at some point in 10, bus arrives, right? And it takes this passenger 2, and it becomes 0. Then at some point in 17, new passenger arrive, and in 20, 20 we take passenger 0. So the best time to the last time we can catch the bus. Why it's not 20? Why it's not 19? Why question is 16 but not 18? So this, okay, because question is 16 because there is a bus at 18, passenger at 18, right? And there is a passenger. And when it arrives, this bus arrives at 20, here we have 3, and capacity is 2. So bus arrives and it will be 1 passenger. So I will not be able to get on the bus. This is why answer is 16. Okay, so it seems that why it's 16? How can I predict this 16 point, right? How I can this point. So in this point of time, here Q will be 1. I can go on 10, Q will be 1. And here Q 16. So it seems like I have to go through time and calculate Q. And every time, so we have last time, with last time, we will calculate mean, demand. And here, if Q, if capacity minus Q if Q plus 1, that means that I can go, right? Then we add last time to equal P, and here we return function. Oh, it looks like our time. Yeah, it looks like a function. Yeah, and we will return last time. Okay. Okay. Yeah, I want to. I kind of like this implementation of my function. I want to implement this. Let's see um, how it will work. So um, let's see if it will work. I'll try running this. So last time we set to we're on 2. We have capacity more than 2. Last time 2. We set also we set here we set should set Q to 0. If we at Q1 no bus, we go back. Now we have Q3, no passenger, no bus. We go 3, 4. Okay. Yeah. Okay. Let's implement it really quick because we kind of reached our half time. Let's implement it really quick. The only thing I don't know how to implement hash map, hash set. I think like this. So we do set passenger and set buses, and then we calculate min max. Then we do sync. I think it's set, but I'm not sure. Either way, it doesn't matter. Um, just language specifics, not like algorithm specific. So range if t in p t in b. It's looking good. I don't know if it's run, but it's looking good. Okay, let's see. Inverse index range in the max. What is typo? Okay, yeah, the position passes. Okay, passengers is not defined. In passengers, typo again. This is why like copy paste is always better than typing. Even if I type fast, copy paste is more reliable. Come on. Okay, so yes, we have a first capacity 2 or 2 expected 61. So we can print easiest way to understand how it works. We just print time and q. In this way, we will see okay. Very funny. Come on. Okay, so 2, 1 passenger, 3, 1 passenger, all goes up to 10. So 10 in mass will Q minus capacity, which is Q and 2. Okay, yeah. So I it's not apps. Yeah, obviously we do this, and if Q less than 0, then Q equals, because apps is still like apps. All right. Okay, so now we have something 10, 0. So 16 should be our last. Why it's getting 18? 17. Okay. Yeah. I still can arrive in 17, right? Because first I arrived in 16. Okay, so I 16. So I feel like I have to move this back here because it's like at the end of the hour. I have to make a decision, not in the beginning of the hour. Okay, we're getting something. So now 16. It's still returning 7. Why it's returning 7? Okay, so 16 times. This passenger go at 16 times is the last one. And 17, if I arrive at 17, at the same time as another passenger. I cannot arrive at 17. Oh, now we're getting something. See, I cannot arrive at 17. You cannot arrive at the same time as another passenger. So if capacity and T in not T in P. Let's call it got passenger. Become more critical. T in P. And so we don't have to search it twice. Got passenger and not got passenger. Alright, it's pretty exciting. Let's make it. Edge cases. Edge cases. I didn't think about edge cases. Okay. Come on, read code. I have like 6 minutes. Wrong answer. Okay, buses 3, passengers 2, 3, capacity 2, output 2. Okay, 1 bus on 2 from 2. Oh, okay. So there is a possibility to arrive early. So should I get -1? I can arrive before first passenger. Yeah, use the case. Okay. Okay, three. So I can arrive then use the case. Okay. That's Princess Guy. So it's running from. But bus will be at three. Okay, so I feel like it could be max, could be max of max, right? Can I do it? Okay, why not? Max of passengers or max of buses? That's fine. Yeah, why not? Okay, first case is fine. 20. Wait, bus at 20. So I cannot arrive at 20. So it's passenger plus one or buses. I can arrive after last passenger, right? But I cannot arrive after last bus. It will be incorrect. Which case is okay? Now it's fair. This one is fair. Okay, one. Why? Mhm. So there was no three. But why? I don't know. Something wrong. Add plus one to it. I know there are like one fail. These like edge cases are failing. It's like, oh, there is a bus on 20. Why I cannot catch bus on 20? Because Q will be till this time. Is it really I should put it here? Because this is the moment when I can catch, if I can decide if I can catch the bus or not. And this is the moment when bus is left. Mm. Okay, I think we're pretty close here, but yeah, I cannot solve it into 30 minutes limit. My time is up. But yeah, I think it's not very efficient, and it's O of n. Time complexity of this will be O n. Then yeah, it will take time for me to tune it and understand why it's not working. Yeah, pretty close. I will work on it more and see if I can solve it. All right, that's it for today. Thank you for watching.